States Army presents The Big Picture, an official report produced for the armed forces and the American people. Now, to show you part of the big picture, here is Sergeant Stuart Queen.
Today on The Big Picture, we invite you to take a look at Fort Monmouth, New Jersey, and some of its many activities which have increased many-fold in importance as science has introduced and perfected its astounding new techniques. On this historic post, where General George Washington once turned a rout of the young American Army into its first victory after the rigors of Valley Forge, you will see how an indispensable part of today's Army trains in an atmosphere which combines the military tradition of the past with the demands of the electronic age.
Located on the North Shore of New Jersey, Fort Monmouth is the principal research, development, and training center for the United States Army Signal Corps. Its objectives are to produce the finest soldier technicians and to supply the very best in modern communications and electronics equipment. But these Signal Corps specialists are still soldiers first. They are trained and ready to join with our allies in defense of the free world. Post headquarters, where under the direction of the commanding general, numerous agencies are coordinated so that the post may carry out its vital work. The largest of the many vital agencies at Fort Monmouth are the Signal School, which trains personnel, the Research and Development Laboratory, which develops new equipment, and the Signal Equipment Support Agency, which monitors civilian production of that new equipment. The Signal School, where over 150,000 military personnel have already been trained. A thorough, intensive training program provides instruction for both officers and enlisted men. Each week, classes of students graduate, students who, through their studies at the Signal School, have increased their military and technical knowledge, and by so doing, their value to themselves and to the Army. The schooling of company, field grade, and staff officers stresses combat leadership in the tactical employment of communication and electronic equipment. Many of these classes are given in Squire Hall, named for the former chief signal officer who originated the then daring idea of sending multiple messages over one wire pair by varying their frequencies. Signal Corps officers may attend the school 3 times during their careers. First for the Signal Officer Basic Course, then for any one of 20 specialized courses, and finally for the 36-week Advanced Officer Course, the highest level of instruction in the Signal School. Any class can illustrate the plan of instruction here. For example, this is an infantry officer teaching signal officers the fundamentals of tactics. The instructor calls on members of his class to outline a plan of tactical action. Taking into consideration the enemy's position and known deployment, the student signal officer begins to outline his plan of operation. Later, using the same tactical situation, signal instructors teach the application of communication systems. The recently developed Army Area Communication System provides the Army with a method of maintaining contact and exercising command control even while under atomic attack. Emphasis is also given to intensive instruction in such purely signal considerations as the capabilities, limitations, and methods of employment of signal equipment. This includes, for example, carrier equipment on which multiple messages may be sent. and automatic data processing systems which use digital computers functioning at electronic speeds. Modern equipment developed for the fast-changing situations of the atomic battlefield. To fulfill their duties and responsibilities in the field, officer students go over a wide variety of Signal Corps equipment so that they may gain a full understanding of their application and use. Also studied is the Army Command and Administrative Network, which provides a military communications system both at home and overseas. Student officers learn the complex operation of the modern Army supply system, which employs electronic computers to speed up the flow of supplies to our widely scattered armies. Included in the 3,000 officers attending the school each year are about 300 officers from our allies, training in signal work under the Military Assistance Program. In time of war, their understanding of our signal methods and equipment would be of immeasurable aid in tying our armies together. To keep the signal school up to date, to meet the requirements of an ever-changing army, requires continuous attention. To do so, the curriculum of the school, its concepts and doctrine are meticulously and regularly reviewed and revised under supervision of the Chief Signal Officer, Department of the Army. For non-resident students, many of whom are at colleges or universities which offer Signal Corps training, texts, lesson plans, and instructional material are prepared. In addition, the Signal School conducts correspondence courses for armed forces personnel around the world, including members of National Guard and Reserve units. The largest department in the school, operating in a complex of 359 classrooms, gives instruction to enlisted ranks. Here, over 9,000 men annually become expert in the repair, maintenance, and use of communication, electronic or surveillance signal equipment. Many of these men enter the school with little or no prior knowledge of the complicated electronic circuits they are to study. A coach and pupil method of instruction is used to ensure maximum benefit by the students. Completely equipped classrooms and laboratories are provided to ensure rapid progress. Within 6 weeks, the students become proficient enough to build complete radio receivers. All departments of the Signal School emphasize the practical application which parallels fundamentals and principles. In the Dial Central Office Repair course, for example, students learn to install, maintain, and repair manual switchboards, automatic dial exchanges, and more complex switching centrals. Enlisted students at Fort Monmouth may be assigned to any one of a number of signal courses. Some are trained as specialists in radar and countermeasures equipment. On the other hand, some are assigned to pictorial courses, which include the repair and maintenance of photographic equipment. They also learn still and motion picture techniques on the ground and in the air. In this manner, the Signal Corps provides tactical photographic coverage. Tied in with classroom instruction is a closed-circuit television network where student technicians learn the operation of TV equipment as well as its care and maintenance. All of the 359 classrooms can be reached by both the instructor's voice and a picture of whatever text, drawing, or equipment he is explaining. In this way, a top instructor may teach simultaneously several classes. Multiple channels make up the system. Instruction is given in maintaining, repairing, and using countermeasure equipment that will jam and confuse the enemy. but to other than the selected student personnel, it is classified. Not all of Fort Monmouth is work. When classes are not in session, students find facilities modern and comfortable. Large dormitory-type barracks accommodate 3,000. There are family-style mess halls, day rooms for relaxation, a religious corner, and modern hospital facilities. For married personnel, life goes on. And of course, bachelors are not overlooked. For physical conditioning and recreation, Fort Monmouth has many facilities. The field house is open to all post personnel, students and permanent party alike. The big modern pool serves both pros and paddlers. The golf course is for the use of all ranks. Much of the post's social life centers around the NCO club and the service clubs. Here the whole family can relax, for tomorrow will be another busy day. Another important agency at Fort Monmouth is the United States Army Signal Equipment Support Agency, otherwise known by its initials as USACISA. It fulfills the function of production manager, making sure that the signal equipment supplied to our armed forces is of the highest quality. As production manager, USACISA's work spans the area from the development of a design to full volume production. During the development stage of all Signal Corps equipment, an evaluation is conducted by USACISA to improve not only the product and its maintainability, but also its manufacturing process. Its evaluation is carried out in the field as well. Working closely with the users of the equipment, USACISA engineers seek out possible difficulties of repair and maintenance. USACISA representatives meet with the manufacturers before production. A pre-production sample submitted by the manufacturer must be approved by USACISA before volume production can proceed. So the agency's engineers subject the model to a series of tests which determine whether the equipment meets all contract specifications. Extreme high and low temperature tests, a water resistance test, a vibration test, a test simulating loose storage of the equipment on the bed of a vehicle in motion. Of the many agencies found at Fort Monmouth, one of the most important is the Signal Research and Development Laboratory. Here, some 3,600 scientists, technicians, and other specialists are working to provide the armed forces of the United States with the most advanced communications and electronic equipment. New ideas are born and developed here. At the same time, a close working relationship is maintained between the Army Research Laboratory and the research and development facilities of civilian organizations, private industry, universities, and foundations, many of whom are sharing research problems. Possible future combat may be nuclear, it may be conventional, it may be large or small, but regardless, it will be electronic. For electronic combat, we need the finest and most rugged components conceived and designed in this great laboratory. A prime example is the dip soldered printed circuit, a lab invention now almost universally used in mass electronic production. The conductors, that is the wiring, are printed on one side of the plastic base, and the components, transistors, diodes, and so on are on the other. Now the laboratory breakthrough, dip soldering. All conductors and parts are rapidly connected and polished. The laboratory's method, patented by two lab scientists, in the name of the United States government, has become the key to miniaturization and automation in the electronics industry. Another remarkable first for Fort Monmouth scientists. In communications, the signal laboratories develop many sets which are lighter, more powerful than their predecessors. Many are fabricated under the modular or building block concept, identically sized assemblies that can be plugged into the chassis to make a complete unit. These sets are a dream of field maintenance come true. Pull out the failing circuit, plug in a fresh one. With these dependable radio sets, communications from and between dispersed forces can continue without interruption. Every link in the radio chain of forward area communications has been made smaller in size, pointing toward the ultimate 10-to-1 reduction offered by the micromodule program. This large 3-unit radio relay, for instance, is being replaced by the single smaller unit at the left. The handy talkie is a small transmitter receiver, but with a 10-to-1 reduction envisioned by the micromodular concept, rugged military radios in the future can be made as small as this fountain pen receiver. In the field of surveillance, signal laboratories have brought forth startling new ways for gathering information about the enemy. Fort Monmouth scientists developed the camera equipment for this radio-guided drone, which can photograph enemy terrain. When flying at night, equipped with flare ejectors, the drone is practically immune to enemy counteraction. This laboratory-developed radio direction finder, with its spinning antenna, picks up a radio signal and points unerringly at its transmitter. It was developed to spot enemy radios, but when the first Sputnik was reported, the direction finder locked onto it and provided orbit azimuth information, correcting the findings of tracking devices elsewhere. In pinpointing an enemy radio or any object, a propeller-like pattern flashes on the electronic viewing screen to give operators a direct and continuous bearing. This huge 50-foot parabolic radar antenna, or dish, is Diana. Its smaller predecessor astonished the world by bouncing a signal off the moon, the round trip taking about 2½ seconds. Diana now does the same thing as a routine scientific assignment. The Space Sentry, a 60-foot aluminum dish antenna, is a pioneer military radio telescope, a telescope that listens. It is capable of recording the weak, faint signals from millions of light years out in space. Celestial objects often give off radio signals. In radio astronomy, these signals are picked up and recorded, even though the transmitting object, star or hydrogen cloud or galaxy, is invisible to optical telescopes. The Signal Laboratory has been most active in the satellite field, providing batteries, crystals, diodes, transistors, and other components. Here is a ring of solar converters, or sun batteries, designed to provide a full 5 watts of electricity for a satellite. To demonstrate, a single cluster from a ring is hooked up to a small electric fan. As the cluster is moved into the simulated sunlight of a wall lamp, the fan turns. Sunlight converted into electricity operates the satellite's instruments measuring cosmic rays, solar X-rays, and other space phenomena, as well as the radios that telemeter the data back to Earth. Since for all practical purposes, the solar batteries never wear out, the satellite will have power as long as it orbits. In darkness, electricity will come from tiny nickel-cadmium batteries recharged by the solar converters. Vanguard 1, the 200-year satellite fired early in 1958, is still sending signals with its solar-powered radio. Of great importance is the laboratory receiving area. This is perhaps the world's most complete and efficient receiving complex for any type of radio signal. Among others, this receiving area picks up transmissions from orbiting satellites. These are Yagis, also called fishbone antennas. These signal corps designed antennas are but two types in a group capable of receiving any type of radio signal. For countdowns on space vehicle launching, the center is connected to Cape Canaveral by direct telephone and teletypewriter lines. Satellite radio signals have numerous scientific values. The laboratory's accurate recordings of these satellite signals have been of great value to agencies connected with the space effort. Orbiting information from the lab is incorporated into official data and provides a standard by which other satellite information can be confirmed or corrected. An orbiting satellite comes into range of the powerful receivers.
There's one coming in. There's one coming in. There's one coming in.
The signal rises as the satellite nears the overhead position, then slides downhill as it passes over, perhaps at 5 miles per second. The satellite is identified on magnetic tape for type, time, and orbit number. Another record on paper tape tells part of the satellite story and also shows that the equipment is functioning properly. These dials indicate recordings on 7-channel magnetic tape storing valuable satellite signal information. Only a tiny fraction of the hundreds of scientific and technical activities of the United States Army Signal Research and Development Laboratory have been shown here. For this lab is the true home of all research and development, from basic study programs to specific nuts and bolts problem solving for the Signal Corps. And this film has touched on only the largest of the activities at Fort Monmouth. There are numerous other small but important agencies based here. Among them, the United States Army Signal Board and Signal Publications Agency, the Signal Patent Agency, and the Signal Radio Propagation Agency. One of the most interesting of these is the Evans Signal Laboratory near Asbury Park, New Jersey, a subdivision of Fort Monmouth Signal Engineering Laboratories. Here, scientists of a special discipline, meteorology, study one of the most baffling factors of man's environment: the weather. For centuries, the weather has been man's master, defying his every attempt at control. Only in recent times has science had any success in predicting the weather's changing moods over a limited period of time. In military operations, the weather can be, and often has been, a formidable factor, either providing a protective blanket for operations or adding another obstacle to the already momentous problems the soldier has to confront in battle. Accurate knowledge of weather conditions is thus a most important weapon, particularly today, when the modern Army, with its reliance on atomic weapons, rockets, and guided missiles, requires more weather information than was ever necessary in World War II. At the Evans Lab, a top-flight group of meteorologists labors to learn when, where, why, and how the weather works. The radio sonde is an example of equipment which has been developed at this laboratory to explore weather conditions high above the Earth's surface. A sensitive and delicate instrument, the radio sonde contains elements which react immediately to all variations in meteorological conditions. A miniature lightweight radio sends back to technicians waiting on the ground the information which the instrument has gathered thousands of feet up. If called upon in battle, the radio sonde will provide vitally needed weather information quickly, efficiently, and accurately to armies on the ground. Today, a revolutionary system of local weather forecasting is being perfected by the scientists at the Evans Lab. For the first time, with this radar weather set, a single glance at the special tracking scopes will reveal the weather picture for 200 miles. The operator of the radar weather set can tell the intensity, the height, the range, and the direction of any storm within that 200-mile area. This special stop-action film speeds up the work of the radar set. Taken during a spell of extremely bad weather, here you see a high-altitude storm moving from Buffalo on Lake Erie past the Evans Lab and out to sea. Here is another of the unusual studies being made. This oversized fishbowl filled with water is called the tornado tank. By creating currents in the water, it is possible to duplicate exactly the action of a tornado. Those little black globules are pieces of soluble dye which will show the action inside the tank. The miniature tornado begins with a slowly circulating ground current. When a persistent updraft is added at just the right moment, the circulating current will begin to wrap itself around the updraft, forming the so familiar twister. The result is devastating. Real houses in the heart of a real whirlwind would be tossed about exactly as these are here. For the power of a tornado is equivalent to an atom bomb being exploded every second. Through this study, the Army hopes to develop a better understanding of tornadoes and a new early warning system as it goes along at its task of seeking to know everything pertinent that it can learn about the weather. Today, the efforts of everyone at Fort Monmouth, military and civilian alike, are directed toward providing our armed forces with the best in communications personnel, techniques, and equipment. For in this modern age, in this day of incredible weapons, the defense of our great nation requires no less than the best. This vital work at Fort Monmouth spans the world and even reaches out into space. That constant progress is made possible by electronics equipment designed and developed at Fort Monmouth is evidenced by this voice from outer space.
This is the President of the United States speaking. Through the marvels of scientific advance, my voice is coming to you from a satellite circling in outer space. Through this unique means, I convey to you and to all mankind America's wish for peace on earth and goodwill toward men everywhere.
In 1778, victory in the Battle of Monmouth gave American troops the incentive to push northward across the Hudson River. Now, victories scored daily within the confines of Fort Monmouth push man's knowledge deeper and deeper into areas still uncharted. Now, this is Sergeant Stuart Queen, your host for The Big Picture.
The Big Picture is an official report for the armed forces and the American people. Produced by the Army Pictorial Center. Presented by the Department of the Army in cooperation with this station.